This is a question under coordinate geometry. It's actually an alright question, just that students tend to mix up and confuse a lot of concepts here. So that's what makes it problematic. Okay, in and of itself, it's actually okay once you kind of sketch out the points, right? So the question says they give you the coordinates of P and Q, and they tell you the coordinates of point R lies on the y-axis. Okay, let's just draw it out first. Okay, P is -2 and 6, so that's somewhere here. And then Q is 9 and 3, so that will be somewhere here. Okay, R lies on the y-axis. So here's one of the confusion, right? Some students they will draw a straight line connecting P and Q. Um, Sorry. Yeah, sorry. So they'll draw a straight line connecting P and Q, and then place R on the y-axis in the middle of P and Q, and then they'll just use midpoint theorem to find the coordinates of R. So this is wrong because the question did not state that P, Q, and R are collinear or that they lie on the same straight line, right? That's an assumption that you make, which you can't, right? You can't presume. Okay, so what you actually should do is place R somewhere else, right? Let's say here, right? We don't know where R is. Let's just put it somewhere so that we can uh, like visually try to figure out what's going on. Okay, we'll call the coordinates of R XR and YR. Okay, but okay, since R lies on the y-axis, right, we will actually know one of the coordinates, and that's X, right? The X should be 0. Okay, if it lies on the y-axis, X will be 0. So that's another point of confusion, because when people hear y-axis, they think that y is 0. That's wrong actually. Okay, you see the coordinates of X will be positive, like as you move to the right of the y-axis, and then it's negative as you move to the left, right? So on the y-axis itself, the X coordinate is 0. So keep that keep that distinction in your mind. Okay. Okay, then the question tells you that PR equals to QR. All right. So we can draw the line of PR, and I'll use another color for QR. So we have to show that the length of PR equals to the length of QR, which gives rise to another confusion, right? Because somehow, just from observation, like a lot of students, they confuse gradient with the length of a line, right? So you have to be very clear what's gradient and what's the length of a line. So the gradient tells you how steep a line is, right? Two lines of different lengths can have the same gradient if they are parallel, right? They have the same steepness. Okay, so in this case, the gradients of these two lines are equal, right? How about length? Length is just that, right? This line and maybe this line, they are of equal length. Let's say this is 5 cm and this is 5 cm, but different steepness. Therefore, their gradients are different. Okay, seems a bit like common sense, but then yeah, somehow it's just people get confused between these two concepts. So watch out for it, right? So in this case, we are not trying to equate their gradients. They didn't say PR and QR, they have the same steepness, right? They say they have the same length. So we need to um, find the length of PR and equate it to the length of QR. So how do you find the length of PR? There's the length of a line, the length of line formula, right? Which actually is derived from Pythagoras theorem, right? If you just take the square of this side and add it to the square of this side, it will equal to the square root of the hypotenuse. So your PR will be equal to the square root of 6 minus y squared added to the difference between -2 and 0. So it's just -2 squared. Okay, so this will be, you can expand it. It will be 36 minus 12y plus y squared plus 4, or y squared minus 12y plus 40. Okay, and then we just do the same for QR. So QR will be the square root of 3 minus y squared plus 9 minus 0, or just 9 squared. Okay, let's expand it. You'll have 9 plus 6y plus y squared plus 81, or y squared plus 6y plus 90. Okay, and yep. So since PR equals to QR, right, you just equate these two. Okay, y squared plus 2y plus 40 should be equal to the square root of y squared plus 6y plus 90. Okay, so how do we get rid of the square roots? Okay, we just do the opposite, right? We square both sides. So you have y squared plus 2y plus 40 equals to y squared plus 6y plus 90. And then you just minus y squared on both sides. You have 2y plus 40 equals to 6y plus 90. Then minus 2y and minus 2y and minus 90 from both sides. So you have 4y equals to negative 50. So y will be equal to negative 50 divided by 4, right? So that will be the y coordinate of r. And we already know the x coordinate of r is 0. So the answer is 0, comma, negative 50 over 4.